Leo, can you hear me, Leo?
Yeah.
Okay. So, Leo, what I wanted to say that to resume what we were speaking about, inside this virtual machine software, inside the laptop or computer, then you have to say, okay, I want to dedicate how many RAM and how many hard disk to actually run this specific image or simulation of this Windows XP, for example, or for even this Mac. Okay, so it means that it will cut from your main RAM and from your main hard disk when it is running. Of course, when you close it, then everything is returned back to your computer. Okay, so sometimes as a developer, if you are developing software for Mac OS or even for Linux, then you have to test it. So most of the time, you don't have too many machines or too many laptops to test. So you have to do this kind of testing inside. And inside this virtual machine, also it's possible that you are able to communicate with this with your original laptop or computer using communication. So you're able to, this will have a network card installed, and then you are able to communicate between both of them. And so that gives many options for you as a programmer to test things, especially if you're doing software that is related to networks. So now let me go back. So this is one of the types that you can do on your computer, but also on servers. A virtual machine also is used on server, but it's slightly different from what is used on computers. So that is how it looks like. So typically, you will have hardware um, like that, and then typically web hosting companies, they will share the web server hardware among many users. So every user will think that he is the only person using the server. Okay, because his software and everything will be running in something called virtual server. So it is possible. So it is possible to utilize this hardware of the server and make many users use it. Of course, inside every virtual machine, also they have to say, okay, this virtual machine server or virtual server actually will take how many RAM, how many hard disk from the original server. So that is used for servers in general. And how to say? Let me see. So you have now two types. One can be used on servers. One can be used on personal computers. And one more thing, there is another software that you are able to use inside your computer, which is actually not for running operating system at all, but actually if you have, for example, this is mostly common in Python. So if you're dealing with a Python programming language, you will find that certain versions of Python is not compatible with other libraries. So if you're dealing, for example, with something related to AI and vision software, so that recognize faces, or you're doing a project that is related to that, so you will find that, for example, Python 7 is the latest supported by most of the AI libraries. So, but the latest version of Python will be maybe 14 or 15. And this 15, if you install it, all your software for your project will not work. So you need to install something called a virtual environment. And this virtual environment, inside it, you will install whatever libraries or whatever versions that you need to run your project. Okay, and this is typical with software programmers, that not all their projects will run with the same version of, for example, Java has Java 7 and have also Java 8 and so on. So not all the versions of Java will actually run on every project. Some of your projects you don't want to upgrade to the latest, and you have to keep running and testing it on the old Java versions. So when you install, you cannot install 7 and 8 on the same machine. So of course you cannot have too many computers to test your software. So they created software that allow you to emulate and isolate this kind of programming language versions. So did you catch what I'm trying to tell you?
Yes.
Okay. And now one of the important things here, of course, is the Java virtual machine. Are you aware of the Java virtual machine? Do you know how it works?
No, not exactly.
So, okay. In short, Java, when you write a code in Java, so it is, for example, food.java as a file. So this file is actually compiled, and when it is compiled, it is the compiler output something called intermediate files. These intermediate files actually become with extension of dot class, and this dot class files actually is not executed directly. One of the core benefits of Java that they say, okay, we don't want to write a Java language for, how to say, for every hardware. We want to write a program that can run on a Mac, on a Linux, on Windows. So how can they achieve that? So because, do you know there is something called machine code?
Oh, yes, I do.
What is the machine code?
It's like it's the code that like the computer like actually like executes.
Okay, so this is the ones and zeros that the computer are able to understand and execute, right?
Yes.
Okay, so okay, every operating system have a underlying hardware, and it needs a different machine code to be able to run on that. So the machine code that can run on Linux is different from Mac OS and different from Windows. So if we want to run our same Java program on the three systems, this is not possible. So the only possible way is that whenever we compile our software, it is created in an intermediate language, and this intermediate language are able to run inside something called a virtual machine. This is Java VM in short, or you can say Java virtual machine. Okay, and you don't see that with your eyes, but to be able to run one of the Java in general, you have to always beside installing the Java programming language, you have to install the Java VM or Java virtual machine. This is a compulsory or a must if you want to run any Java program on your computer. So it means that for Windows, there is a Java virtual machine. For Mac OS, there is a different Java virtual machine. For Linux, it's a different Java virtual machine. Okay. And so, but at the end, that means that your software, once compiled, it can run on any virtual machine the same. But the virtual machine itself will be different. Okay. Does this make sense so far?
Yes.
Okay, good. So any of these three, if you mention it in the answer, any of those, no need to mention all, any of those can be mentioned in your answer and it will be accepted. Okay, is this clear?
Yes.
Okay, now we go back to this kind of question. So identify two usability problems that can occur in a voice recognition system.
Two usability problems. Okay, one is that uh, the system may not be able to recognize certain accents.
Excellent. Okay, so let me come here. So first, yes, it's true that accents and dialects cannot be understood. Speech clarity also, it is one of the problems, like mumbling, unclear pronunciation, and also background noise will also affect understanding the words. Another thing is that there is a limit. The voice system normally come with limited commands, so they are not trained to actually recognize every possible command. So that is kind of a training problem. Okay, um, and yes, that's two of possible answers. Now, what is concurrent processing?
Concurrent processing.
Yes.
It's when multiple tasks are executed at the same time.
Can you tell me what is the difference between multitasking and concurrent processing?
I think concurrent processing is the one where different amounts of processing time are like allocated to different tasks. Is that it?
A different kind of cores inside the processor is dedicated to different processes. Yes, this is concurrent. Yes.
Yes.
What about multitasking?
Uh, Multitasking is the one that, so concurrent is the one that makes use of multiple cores, and multitasking is the one that, uh, yeah, it's talking about like one core doing multiple tasks by
So one of the
yeah,
benefits of having an operating system is to actually do the multitasking.
yes.
It is somehow tricky to I mean it's made that, so maybe you can, how to say, um, trick the user to think that we are actually multitasking. But in reality, we only have a limited kind of resources. That was true before the cores started to appear inside the processors. Last time we only have one core. And so we would always like to trick the user that the computer is always responsive to him. So whenever he moves the mouse, like I told you before, then we will interrupt everything that is running inside the processor, and we will try to respond to the mouse movement. And that actually stops the processor and actually is costly. So if you're doing an important operation, you should never play with the keyboard or even with move the mouse. Uh, so when we start to having multiple cores, so the concurrent actually appears. So one of the examples, if you're having multiple cores, and for example you are having antivirus that is working, and maybe you are having a spreadsheet, and then no, this is a spreadsheet, and maybe you are chatting, so you have like and maybe possibly listening to music or even surfing. This is a web browser, for example. This is antivirus, and this is spreadsheet, and this is a chat. So if your processor have two cores, so he will dedicate two of the processors or the application, two applications to one core, and these two applications will keep taking alternate cycles from the core to process whatever needed from them to be processed, and the other two, the chat and spreadsheet, will share another core, the second core, and they will keep working or stopped on and off to have access to the CPU processing or the core 2 processing power, depending on the need, so that all the four processes that is running will actually run simultaneously. So this is kind of an example of concurrent processing. But then I would say identify one advantage of concurrent processing. I think we already said this, right?
Yes.
Okay.
Yeah.
So now let me see. Let me see. Yeah. Okay. Now, tell me, please, what can we do for that recursion? He is determining that we have this kind of function, and he would like to see what is the output and what of if we pass here to this function n equal 1 to 1 6. So this is general, and this is the base. Can you still recall back?
Yes.
Okay.
Okay, so well, first of all, 1 to 1
Would you
6
like
is,
me to allow you to share, and then you can tell me what could be possible answer?
no, I don't think I need to share. I can just work this out.
Okay. So if n bigger than 0, I would say this is the first input, right? When we pass, and definitely this is bigger than 0, so it will never come
Yes.
on the base case, right? So
Yes.
tell me first. This is we do it one by one. So it means that we will make another call, but with this condition, right? So n mod 10 is equal what? So
10 mod
if
10 by 6.
it give you 6 here, okay, but why you say like that? Is it 1 to 1 6 mod 10 give me 6? May I know how you came up with this answer?
A modulus is to one that shows the remainder, isn't it?
Yes, it's true.
Yes. So 1 to 1 6 divided by 10 is 121 with 6 remaining.
Excellent. Okay, good. And then function n div 10.
121.
Okay. And so here on the second call, we will find ourselves so 1 to 1, and then mod 10
1 mod 10 is 1
plus
12.
okay, and then when n
And equals 12, 2 plus 1. Then that's 1 and then plus
1 plus
0, which returns a 0.
okay. So now how to add whatever we got out from here?
Well, we just add all of the results from the mod together.
Are you able
So
to add
6,
them?
1, 2, and 1. So we get 10.
Interesting. Okay. Okay, that's excellent. Yes, yes, yes. So, Leo, I know you are smart enough, but I think I mean, putting that in writing in the exam, I think is excellent. And he also would like to see that. Another thing here, did you use the purpose of this recursive method?
It's
So,
adding up the digits in the number.
okay. So a software company has been employed to program and implement a new system proposed by the system analyst. Explain why software testing is important at all stages of implementation.
Testing is important because it allows errors to be identified and it is important to get rid of errors at every stage of implementation, uh, so as to ensure that the system functions properly.
Okay, so yes, it's true that testing is required to get rid of errors, but you have to also understand that actually we don't call it errors, we call it bugs, because so at certain times when I give you exercise, you are able to run the software, but it doesn't provide the proper output. And then at certain times, yes, you're able to compile and run the software, and it provides some output. And at certain times, also, you are able to produce an output, and the output is correct. But this output, at certain when you are giving certain inputs to that program, it will not output things correctly. So the testing is actually to fix bugs when if you have a normal input, the software is working. But if you have something called extreme input or even marginal inputs, then the software also will not function properly. So just an example. Uh, if you design your software to deal to maybe calculate certain amount of to let me think of a proper example. So if you write a function inside the Java, and this function is supposed to count or make a recursive call, for example, the one that we have done just now, and we we pass this function 1216, and it should work like we have tried a while ago. But then if you test that function with something like this, and maybe 2, 8, and 1, and 4, and 6, and maybe 8, 9, 7, and so on. So if I put here 20 or 30 numbers, so that is an extreme input. So I tested my function typically the programmer tested the function um, using a simple input, okay? And maybe he would test it with 0 and it will work. So he would test it with a normal number, but he typically very rare that you will test it with extreme. So testing your software with extreme input or even unexpected input from the user typically actually produce can show you what bugs you have in your software. So that's why testing is actually dedicated to software testers, and typically the programmer is not able to discover all the bugs in his software. So like if you see your software, most of the time you never checked what the input is. You never checked, for example, if your input is empty. If you are taking an input here, you never checked inside your software if your input is bigger, n is bigger than 0. And most of the time, if you're taking a string, you will, most of the time, most of the programmers also will never do it, unless they are experienced one. So they will never test if they are taking a string as an input. They will never test that the string is empty first before they start to do the function, or to write the function inside, that they are trying to do with the method or the function that they are writing. So that is why software testing is important, because they always test with the extreme. So and also another thing, just to pass to you here, that software normally is written by many programmers, and those many programmers produce different parts of the software that need to be integrated together. So when the software is integrated, typically they have a problems, and this problem only can appear by testing. So everybody is testing his software alone, but when you combine all of those, uh, only by testing you're able to discover which portion of the software fails because of the integration and so on. So that is in short. So again, one of the most important aspects that you need to highlight, that you need to test your software with typical, extreme, and invalid data as an input, for example. Okay. So now assume that we're dealing with a software that deal with images, and we say images are sometimes larger than the limit placed on email attachment. For example, a 60 megabyte image file need to be sent by the email without losing the quality. But a larger file than 10 megabyte cannot be uploaded as an attachment. Describe how large files can be sent by email.
They're using compression.
Okay, and sometimes the compression will not actually do the final job. So it means that it's very hard to reduce from 60 to 10. So what besides the compression that we can do? Compression alone is not possible, because compression will never make you reach from 60 to 10. That's very hard.
Well, what you could also do is you could upload the image somewhere online and like email the hyperlink to the
Yeah, that's
through email.
perfect. Yes, if you tell you use a Google Drive or even a Dropbox as an example of a place that you can upload the image and put the link, also that is part of the correct answer. Another way is that you, after you compress using maybe seven zip application, and as an example, he allow you to actually divide that zip file that you created, the single zip file, into smaller parts. He allow you to also control the size of the smaller parts that you want to divide. So if you have a 60 megabyte and you divide it by 7 or 8 files, um, after being compressed, then you will definitely end up with a smaller size portion for email attachment. So you need to send 7 emails with to be able to send the whole file. So now state one other hardware or software problem associated with using images. This is a kind of question that is actually quite hard to answer, I believe, because this is an open end, and typically that's not part of a fixed syllabus. That's quite weird, for a weird question that I believe so. So Leo, sorry, we have to close and open.